All right, here's our video today, our fourth video in pre-calculus, invertible functions. What are invertible functions? Well, the word invertible just means flipped or upside down. That's all it means. So the input on a domain and range box has to have a unique output. That's for any function. But in invertible functions, the output can only have one input. So let me explain that. Let's draw some. Let's get a clean page. Now we have this bright color, this magenta-like color, or something like that. Why don't we use yellow? So let's say we had the X and the Y, and we'll make a little box. And let's say, we just had A and B and C. I'll throw in D, why not? And you had 1, 2, 3, and 4. So we know the X is the input, the domain, and that's the output, the range. So if A maps to Y at 1, and B maps to 2, and C maps to 3, and D maps to 4, we know here we have a function because you have 1x for 1y. But it's invertible because the output only has one input. So the 1 only has one x. So this is a function, and it's invertible. It's an invertible function. All right, let's make a few more here. What if we had, and sometimes you see them like this, well, better ovals than that, but let's say we had 1, 2, and 3, and A, B over here, and 1 map to A, and 2 maps to A, and 3 maps to B. Well, we know this is a function, right? The output, remember this is the Y, the output could have many inputs. So this is a function, but it's not invertible. Do you know why? Why is it not invertible? Well, because remember we said the output can only have one input. So you see this output here, A, it has two inputs. So it is a function, but it's not invertible. Let's do another one. Let's clear that out. Let me just change the color. What if we had, we'll make a box this time. Could be anything, doesn't matter. What if we have 1, 2, and 3, and then again, this is the input, the X and the Y, the output. And we had A, B, and C, and 1 maps to A, and 2 maps to C, and that's it. Maybe we'll have a 4 over here. 4 maps to C. So again, what we have, 1 does map to A, so that's fine. But as you can see, we're missing the 3 input is mapping to nothing. So this is not even a function. Not a function. All right, let's keep going. All right, change the color a little. It was getting a little too bright. So again, invertible functions, they have to have where the output has one input. They have to be where you can take the inverse function and it maps the inverse. So we did inverse functions the very first video. So let's just give you a very quick, make sure we have maybe we'll stick with green. Should we stick with green? Let's do it. So we did inverse functions the very first video. So let's say we have a function here, 2x plus 5, and we want to know the inverse of that function, which is written like this with a little -1 up there. It just means inverse. So what would be the inverse of this function? I'll just do it very quickly. If you need a little more review, just look at the first video we did on inverse functions. It's basically the opposite function. So what you do is we're going to basically say here it's y equals 2x plus 5. So in the inverse, we're going to just inverse. We're going to make x equal 2y plus 5. We're going to be switching them. And then solve for y. So here we'll minus the 5 on both sides. And we're going to have x minus 5 equals 2y. And to solve for y, we have our inverse function here. So the inverse function will be x minus 5 over 2 equals y. That's the inverse function. So how do we know that it's an inverse, and how do we know it's invertible? Well, let's take the domain and range box over here for the original function, this one. We'll change the color to white. And let's say x was 0. So if x is 0 in this function right here, 2 times 0 is 0, we know y is 5. So let's make a x and y box over here. If that's the case, if this equation right here is right, that means that when x is 5, y should be 0. Otherwise, it's not an inverse. So let's see. If we plug in 5 over here, 5 minus 5 is 0. 0 over 2 gives us 0. So far, it's right? What if we had here that x was 5? So 5 times 2 is 10. 10 plus 5 is 15. So if we did the inverse, and if x was 15, would y be 5? So let's see. 15 minus 5 is 10. 10 divided by 2 is 5. See, it's working out. And let's do one more. Let's do if x was 15. So 15 times 2 is 30. 30 plus 5 is 35. So in the inverse, now x should be 35. 35 minus 5 is 30. And 30 divided by 2 is 15. So as you can see, it is an inverse, and it's invertible. Both are invertible because the x input is mapping to 1y, and the output has one input. All one input. So this is a function, and we created an inverse function, and it's invertible. So invertible functions have to have an inverse to them. All right, so again, just a quick review. Invertible functions have to have one output to map to one input, and vice versa. All right, that's our video today.